Hello everyone, welcome on this e-learning platform of Beck Institute. Here is the information about the instructor and the course. In this video we will learn motion under gravity. So let's start. This is motion under gravity. Till now we have understood straight line motion. If we take any example of straight line motion which is most obvious in one dimension, then that is the motion under gravity. So that's the most obvious and most important example. In this type of questions, until and unless stated, we will take something as a for granted. For granted things that we are going to consider is acceleration due to gravity is a constant. This has a constant magnitude which is 9.8 meter per second square, as well as the direction which is vertically downside. So we will treat as acceleration acting vertically downside, and this A will have a value equal to G, where G is a value 9.8. In some cases we will also take it as a 10 to make our calculation simple and to quickly get answers in objective type of questions. And then another presumptions or for granted thing that we will consider is the motion in vacuum, which does mean that there is no other force acting except the force of gravity. Taking these two assumptions, we will be solving the problems. In motion under gravity there can be three cases. One, when we make any object to fall freely. So if we release any object from height, you will find it's going to go downside. Another case would be when we throw any object from a high place vertically downside, so it's going to go downside with a faster velocity initially. And the third case would be in which we will be throwing up an object upside with a particular initial velocity. So let's deal this case by case. In this case, one where the freely falling bodies are to be considered, the initial velocity we will find to be 0. So an object is being released from a particular height and the ground is somewhere downside. So this will be the initial direction of motion, and A is also downside, so we will take the downside direction as a positive. So direction of motion is being considered as a positive. So acceleration A will become plus G because the direction downside is taken as a positive. At any time t, velocity of the particle will be vertically downside, which is positive. So V is equal to U plus AT from the first equation. This will lead to a simplified equation, V is equal to GT. So that's the one equation we are going to use to solve the problem in case of free falling bodies. Now another equation that we will be using is going to be second equation, h is equal to ut plus half at square. That means the distance up to which it has come down, or rather we should call it as a displacement, vertical displacement h. So this can be written as u is 0 half gt square. So another equation will become h is equal to half g t square. Then similarly, using a third equation, we will get v square is equal to 2gh, simply because initial velocity is 0. So these three equations will be known as equations of motion in case of free falling objects. We will be using them to solve our problems. And the second case would be downward projection. Initial velocity this time is u, downside. So we will take the downside direction as a positive direction. As per this, initial velocity will be positive, u, acceleration will be positive. So the first equation of motion will give this equation. Then the second equation of motion will be used as h is equal to ut plus half at square, and the third equation will appear similar as usual. So these three equations are used to solve the downward projection motion. Figure is here. That's a t equal to 0 scenario. That's a t time. Initial velocity is u, final velocity is v, the displacement is h, and g is vertically down. Thank you.